Hey guys, this unit that we're starting here is Unit 8. It's geometry. There's a few things we'll do in it. The first thing is drawing parallel lines. So we're actually going to draw them and also, be able to point out and recognize them. Then we'll talk about perpendicular lines. So I'll define them. We'll talk about bisectors and constructing, like drawing perpendicular bisectors. And then we'll talk about angle bisectors. That will take us to our mid-unit review. After the mid-unit review, we'll be looking at graphing using coordinate grids. We'll graph translations and reflections. We'll get to that, what that means. And then we'll graph rotations. These are all skills that are super useful in various trades like construction. It's useful in plumbing. It's useful in mechanics. It's useful for different mathematics and physics, astronomy. There's a lot of uses for this type of math. And it's useful in art, various types of visual art, or even instrument building. So let's start with parallel lines. That's what 8.1 is all about. So, all right, so I've drawn a bunch of line segments, and I call them line segments because a line would just continue and continue for as long as it can, eternity kind of thing. So right here I've drawn what are called line segments. So there's a fixed end, there's a point. So all a line is a bunch of points, dots, a limited infinite amount of points, dots, between one point and another. Now, the ends of these lines and in a couple of spots, some sectors or some division points they're all labeled. So we've got point A is the end of this line, point B's here, C's here, D's here, so forth. Now, what I want to ask you is which line segments, so we have line segments, which ones are parallel? So looking at this, what parallel means is if the line segments would never cross if they were extended, then they're said to be parallel. So for example, here's one example, equal sign. An equal sign, if drawn properly, these two lines, no matter how long you extended them out, one way or the other, those lines would never cross. So the equal sign is one example of a parallel set of line segments. Now looking here, we've got from A to B, so line segment AB, that one is parallel to FH. I recommend keep things in alphabetical order, okay? So keep them in alphabetical order. And also choose the points that are furthest end. So let's say there's like a point here that was I. Choose the ones that are at the far ends, okay? It just makes it clear that everything along there, take the furthest end. So don't say HI, even though HI is actually parallel to AB. Try to keep things both in alphabetical order, but also take the ends of the lines. So if you're going to be talking about this line across here, say BF, don't say BE. Okay? As well, it wouldn't be considered another line to say BE or BF. Those would be technically the same one for some of these questions that you'll be doing. Now, there's actually another line that's parallel to these. Just because these are across from each other, it doesn't mean that they aren't parallel. Technically speaking, right here, AB is parallel. If you take your ruler and line it up, straight line, the edges of the ruler, they are parallel. This CD, this line, is actually parallel also to AB. So AB is parallel to CD. Okay, so those are parallel lines. Where you would not say that G and E, so let's go EG, keep it alphabetical, is not parallel to AB. Why? Because if you were to extend these lines out, there is a certain point here that they would intersect. If you extended those lines out, use your straight ruler and extend them out, there is a point here that these lines would cross if those line segments became lines. Okay? Technically speaking, CD here and FH, they would actually technically be the same line if they were to be joined. If these line segments were joined, they would be the same one. So here you could have also said CH if there was something joining here. That's a little more complicated than I need. One other definition of parallel lines is if you were to take the perpendicular, so perpendicular is the right angle, it's the exact 90-degree angle, so it'd be the same angle from here to here as here to here. If you take your perpendicular line all the way across, it would be the same measurement. So if I take this ruler and measure all the way across, line up the 0 with the line, here it would be 3.5 centimeters, 3.5 centimeters, 3.5 centimeters, 3.5 centimeters, all the way across. They are always equidistant. They will always be the equal distance from each other. So that's another part of this definition. So from one parallel line to another, they'd always have that same equal distance. Now, if you were to make it not perpendicular, but rather, a little off one way or the other, then obviously it wouldn't be, but it needs to be that perpendicular line, which is what 8.2 lesson is all about. Now, the majority of this lesson is actually going to be about us drawing parallel lines. Now, one easy way to draw parallel lines that when it doesn't really matter how far away they are from each other, if it's just, hey, draw two parallel lines, well, you could take a ruler, draw on one side of it, and draw on another. Voila, parallel lines. Simple as that. Or you could carefully draw along this blue line and this blue line. You could say they're parallel. Now there's a symbol we use for parallel lines. We put arrows on them. So we put an arrow here. That line segment is parallel to this one. So any that has one arrow, we're saying that those are parallel to each other. So this line would be parallel to this, and in this picture, this one that has two would be parallel to the other one that has two. Doesn't really matter which way you put those arrows. Now that's one way you could draw them. Another way you could draw them is using what is called a compass. You'll need to get one of these. You could also use a protractor, which is those round things that come with the geometry set. I recommend getting one. You don't need one for this unit, but it would be helpful. But with a compass and protractor, you could do a very similar thing. Let's say we've got this line segment. You can take your compass, okay, stick it anywhere on here, and do an arch or arc. Ooh, mine is skipping. Sorry about that. Okay. Until it starts to come back down. And then you can pick any other point along the line, put the pin, and arc it around. Oh, mine wobbled there, but that's fine. I'm worried about this point up here. And then you take your ruler and place it on top and work your way across. I'm just noticing that these aren't actually perfectly parallel, but it's because mine is kind of wobbly. If yours has a screw on it, you just take a screwdriver and tighten it. I'm going to go do that now before I do my next way of drawing parallel lines because it needs to be tight. I was going to tighten it before, but I realized maybe I shouldn't so that I can illustrate that. When it is tight, you're able to, shift it to the size you need it to be, but when you go to use it, it won't just slip out like happened here and didn't make a nice edge. I have hiccups. Sorry about that. So if I click here, if I put my pin on this line now, let's draw a parallel line to it. Just spin on the top. Find another spot, doesn't really matter where, on the line segment, and do another one. Set my ruler on top and draw across. Voila, parallel to parallel. Okay, so that's easy to do if there's not a certain distance away that it needs to be. we're going to do another question here that's a lot trickier, and you're going to need to be able to do this. I'm wanting you to do a Zoom meeting with me in order to do this. Here's what the question works like. So during my office hours, tune in so that you can show me you know how. Here's how the question goes. There's a line, and you need to draw a line segment that is parallel to this, but this dot right here is part of the line. Okay, I've just taken this. Now, I've seen some people try to do what we did up here, and you know, they took their compass and they tried to adjust it so it was perfectly that distance. You know, they did that. But how do they know that they have that perfect tallest distance there? How do they know that, you know, they don't have it a little bit off? And now I'm doing extreme. I'm a little bit to the side, and then when I draw my circle, it actually arcs way up, right? How do we know that we're getting it exactly this distance here? That would be perpendicular, that perpendicular line. It's not easy to do. So what we need to do is follow some steps here that are illustrated on page 301 of your textbook. Okay, that's another explanation. It's what I'll be following, a very similar route, and I hope that my video will explain it a little better. It is somewhat complicated, but once you get these steps and you do it a couple times, please practice it a few times, it will become easier. So on your book, they basically said this line is segment A to B. And they said that this point is going to be called C. The first step is make any point D on A to B. Any point. Doesn't really matter. I'm going to just draw a little point here, and I'm going to call that D. Okay? What you're going to do is place your compass point on D. And then you're going to set the pencil. You're just going to grab here and pull until pencil is on C. So that means that the distance between, so the displacement between this pen and this pencil would be equal from this D to C. So if like I took a ruler and I measured this distance or displacement, I would have the same amount, okay? And you're going to draw a circle, okay? You're going to draw a circle that crosses AB. Now I'm noticing here that I made it a little bit too small. So I'm going to redo that one. This is the second compass tip I have. You need to make sure your pencil's sharp. Okay? So let's do this again. Put the pin in there. And let's draw the circle again. Voila. Doesn't necessarily need to go all the way around, but I'll draw it anyway. It just needs to make sure it crosses goes through C, crosses A, B, and maybe just a little bit over both ways. So I'm drawing some steps here. Put a point on AB, label it D, doesn't matter where. Then put the pin of this on D, put the pencil on C, and draw a circle. Then you're going to label E. The point here on this circle that crosses AB, this point right here, we're going to label that E. Okay, so our compass is already at the same size, okay, from D to C. And notice that it doesn't change. This distance here on this compass doesn't change, and it goes here and crosses E. Okay, you're going to lift this up, and you're just going to flip it around and put the pin on E this time, which means that the pencil would then line up with D. See that? Okay, and now you're going to draw a circle through D. So let's spin around here and draw our circle. It's actually okay not to push too hard because that way it glides. I've also noticed that if you tilt it a little bit and just use the top spindle, it glides nice and easy. Okay? Sometimes it's okay if you have to go over it a few times. Okay, I'm going to write down the steps. So you're not going to change the compass size from the first circle to draw the second circle, and you're going to put the pin on E and draw it through D. Now that we have that, we are going to take our pin and put it on E again and adjust it so that it's the size of C. So it's going to be a little bit smaller here in this case. We're going to make it a little bit smaller so it lines up with C. Okay? But we're not drawing the circle there. We are going to lift it with that measurement and put the pin on D, that same spot. And using the measurement that would be E to C, you're going to draw a circle with the pin on D and draw this circle. You need to make sure this third circle crosses the second circle you drew, which is right up here. Depending where you put your D to start, your D point on AB, the circle is sometimes smaller, sometimes bigger. Now this final thing here, this point right here where they cross, this point right here, we're going to label that point F. And now what's really cool is this line that would segment that could go through C and F is actually going to be, let me line this up. My camera was in the way, I bumped into it. This line right here would actually be parallel to point A, B. So I'm going to walk through this quickly. There's a line AB, pick any point on it, call it D. Take your compass, put the pin on D, move the pencil to C, and draw a circle. Lift it up, put the compass pin where it crossed that circle, draw another circle. Lift the compass up, or leave it in the same place, and just adjust the compass so that now it's still on that point E, but you have the pin size of pin to C. Don't draw a circle there. So the third circle, you measure with C, but you lift it up and move it to D, and then draw the line, or the circle around. Where it crosses, the second and third circle cross. So where 2 and 3 cross, label F, and then draw a line through F and C. That is how you draw a parallel line through any point. I'm going to do it quickly, just walking through one more time if you'd like to watch. Otherwise, you are ready to start the assignment. All right, I've got this line here, point C. I'm going to call this one D. Take my compass, place it on the line on D. Move the pencil till it's at C. Draw my circle so that it crosses AB and goes through C. Lift this up. I've labeled this E, which is just the next letter in the alphabet. Keep it the same size. Keep the same size. Don't switch it. Put it at point E where those cross, and then draw the circle. It should go through D. If it doesn't, that means you accidentally switch the size. Okay, good. Then you are going to leave the pin there on E just to get a measurement to point C. The third circle, you measure in one spot, but you move it so that point D right here is where the center is. So it's the distance from E to C, which we now have from D. We're going to have the same distance, and where it crosses that line, that second circle where 3 and 2 cross, that is going to be F, and then we draw a line through those points. And those will be equal distance. They're about 3 centimeters, 3 centimeters, 3 centimeters from each other. So this line is parallel to this line.